We're now ready to turn to multiple group LTA. Slide 59 then. We're going to use the same data set as before early on in this talk for multi-step analysis. We're going to treat the binary x1 variable as a group variable. Could be male female, for instance. And we can do that by specifying x1 as a perfect indicator. I'm going to say what that means, of a new latent class variable c in addition to c1 and c2. Sometimes you can specify groups as known class in mixture modeling, but that's not allowed with BCH training variables. So we take this tack instead. And it's a good approach that can be combined with 1-step, 2-step, 3-step, and BCH with or without imputation of missing data on X's. And you can get quite a lot of model flexibility using the dot language, specifying particular combinations of latent classes. So where you bring in C and C1, C2. And where any parameter across these dot commands can be different or held equal across any combinations of latent classes. On slide 60 then, we first take a look at multiple group analysis for regular LTA, so not multi-step yet. So we have these class variables C with 2 classes corresponding to x1, as we will see shortly, and C1 and C2, both with 3 classes. We have to then specify x1 as categorical in addition to the latent class indicators, because it's going to be yet another perfect indicator. Slide 61 then, and we have the overall model. Since it's regular LTA, we have C2 on C1, and we also regress both C2 and C1 on C. So they can be different as a function of the group. And here's a new feature. We have not only model C1 and model C2, but also model C1 with 2 classes. And we say then that x1 variable, it is categorical, binary. And we're saying that its threshold is either plus 15 or minus 15 fixed. So very high or very low. Very high threshold means that it's hard to surpass it, which means that the probability that x1 is 0, the lowest category, is 1. And it is that way for C class 1. And here we have a very low threshold, which means it's very easy to surpass it. So x1 is equal to 1 with probability 1 for C class 2. So x1 defines the C classes, the 2 C classes, by an observed perfect indicator. The rest is the same then, model C1 and model C2 with its measurement invariance. Slide 62, we turn to multiple group, multi-step LTA. So we do multi-step now instead of regular LTA. So here's the first step of BCH. Same data set, and we have 3 latent class variables as before, and we want to save the distal outcomes for a second step analysis. And you do not have C on C or C2 on C, C2 C1 on C. Those are both commented out. And here we define the perfect indicator, and here we have the measurement invariance. And since we want to do BCH, we save BCH weights. Slide 63 then, last step of BCH. Here is the data set, here are the variables in the data set, and we're going to use Y1 through Y3 here, and training data. And categorical is Y1 and Y2, and Y3 is continuous. X1 is not included here now on the indicator list. And we have C on C here in the overall model, where the Y thresholds and means vary across all the 18 combinations as the default. So 3 times 3 is 9, times 2 is 18, 18 combination classes. And then slide 64, we get a strong sign of BCH failure. And it turns out it's an error for relating to the middle category of the ordinal distal outcome Y2. So here, for instance, in class pattern 113, variable Y2 has a negative frequency for category 2. So here's one of those negative frequency problems of BCH that I mentioned on a previous slide. You know, we had negative variances, negative frequencies, possibilities. So and we have a couple of those problems for Y2 in category 2. Y2 is ordinal with 3 category. This is the middle category. So we have a problem here, BCH failure. So on slide 65, we instead turn to two-step. On previous slides, we had BCH failure, but now we turn to two-step as an alternative. On slide 65, we have then, in the last step of two-step, C-on-C statements here. Oh, we should also note that the categorical list then includes the indicators and X1 and Y1, Y2, whereas Y3 was continuous. So down here, to the bottom left, we have the perfect indicator specification. On the right, we have the fixed measurement parameters for time point 1 that we get from the first step analysis, asking for S values. Next slide, we continue with C2, and we see that we have the same values for C1 and C2 because of the equalities. And then we get results here that we're going to focus on slide 68. We're going to take a look at the threshold estimates for the distal ordinal Y2 variable, where we had that problem with the middle category. And we're going to compare two-step and BCH for this specific latent class pattern 113 that was first indicated as problematic on a previous slide. So the thresholds then for Y2, since Y2 has 3 categories, it has 2 thresholds. For two-step, we see that the thresholds are the same, and therefore leaving no room for anybody in between of the 2 thresholds. You know, you have people below the first threshold, you have people above the first threshold, below the second, and you have people above the second threshold. Those are the 3 observed categories for the Y2 variable. But when the thresholds are the same, they collide, and then nobody is in that middle category. And that's okay for two-step. They collide, but it doesn't hurt the estimation. It doesn't come to a halt. And it just reflects that nobody is in the middle Y2 category for latent class pattern 113. It's not an empty latent class pattern. There are people there. They just have those people who are in there in that latent class pattern just happen to have nobody in the middle category for Y2. Now for BCH, however, those thresholds, look at them. Second threshold is lower than the first. That doesn't make sense. Thresholds should be increasing in value. At most, they should be the same. They can be the same, but otherwise they should not be lower for the second threshold. So BCH has a problem. It's not okay to have those kinds of thresholds, and you get a BCH failure due to negative frequency, like we saw. But the two-step solution is quite usable. Now there's also a little twist here. You can change the Y2 ordinal to a nominal variable to get BCH results if you insist on that. And it says here nominal Y2, it should say nominal equals Y2 here. So that's another alternative if you don't like the two-step results. But that's more of a curiosity.